Good afternoon, and thank you all for joining us for our webinar today as we take a look at how you can transform SOLIDWORKS into a powerful piping and plant design solution. Today, our webinar will be led by Connor Houghton, one of our account managers here at CAD Micro Solutions, and Michael Mooney, Technical Director for North and South America at SMAP 3D. Before I hand things over to Connor to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we will save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the GoToWebinar panel as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow, so if any questions do arise afterwards, you can feel free to respond to that email, and we'll be in touch shortly. All right, without further ado, I will pass things over to Connor to get us started.
Thank you, Madeline. As Madeline mentioned, we are going to be covering process piping and plant design in SOLIDWORKS with SMAP 3D. As that title suggests, we are joined by our friends at SMAP 3D to investigate their gold partner software. My name is Connor Houghton. I am an account manager here with CAD Micro, and today I'm joined by the technical director in North America for SMAP 3D, Michael Mooney. Together, we're going to be covering a lot of ground in this session. So as Madeline mentioned, questions may pop up along the way, and you can feel free to answer or ask those questions in the GoToWebinar box at the side of your screen. It will be recorded, and you will receive a recording after the session is done. You can feel free to respond to that email you receive after the session if you have any questions that come up after the session is done. To kick off the presentation today, I'm going to be going through a quick intro of CAD Micro and SMAP 3D. Then Michael will go over what a typical workflow of SMAP Intelligent P&ID and piping would look like. And then Michael will go over plant design and isometrics. At the end, as promised, we'll answer some of those questions and take some time to do that. So for those of you that aren't as familiar with CAD Micro, we are a Canadian-owned and operated company that has been around for about 38 years now. Our headquarters is in Toronto, but in recent years, we've opened up offices across Canada in an effort to get a little bit closer to our customers. We have a team of professionals here that has been consistently growing over the years, and we're going to have to update some of these slides soon with all the new faces coming aboard. In the session, we will be discussing SMAP 3D, which I've mentioned is a gold partner of SOLIDWORKS. This ties into the design sector of our business, but as some of you may know, we support a range of advanced technologies across 5 different areas. First off being that design software, which includes SOLIDWORKS and its associated partners. Second is additive manufacturing. We also support advanced simulation, 3D scanning or metrology, and finally AR, VR, and mixed reality. We pride ourselves on providing a wide range of advanced technologies for our clients to help them innovate and succeed in their business. If you have any interest in any of these technologies, please feel free to reach out, and we would be happy to take a bit of a deeper dive in each of these areas. All right, getting back on track here with SMAP a little bit more. SMAP consists of 3 basic modules, one of which is P&ID, secondly, piping, and third, isometrics. The most important part about these 3 modules is that they're interconnected with each other. This means that the data defined in your P&ID will also be available across SOLIDWORKS, as well as SMAP 3D piping, and in your isometric drawings. This includes tag numbers, pipe specs, and more of what you would be defining within that P&ID. The way SMAP ensures a consistent process workflow and reduce errors along the way is by having this connection. I won't jump too much into the software here, as Michael's going to go in an in-depth overview himself, but from a bird's eye view, this is how SMAP ensures a consistent workflow for plant designers and process engineers. So I'd like to launch a poll here. If Madeline, you could get that first question going. We want to get a bit of a perspective as far as who we have in the meeting with us. So I'll let Madeline launch that first question. So our first question is, does your company use piping and instrumentation diagrams? I'll give everyone a little bit of time to answer the question, and then we'll take a look at the answers. So my apologies, I read out the wrong question there originally, but do you require single line isometric pipe spool drawings, Isogen drawings for fabrication? And it looks as though we got a close one with some of you saying yes, some saying no, you prefer project views created in SOLIDWORKS drawings, and some of you aren't quite sure what I was asking there. Interesting kind of across the board. Some are and some aren't. We'll look into our second question here before I pass it along to Michael. So Madeline, the second question there, would you be able to launch that? So there we go. Does your company use piping and instrumentation drawings? Got a couple answers for you to do there. So I'll give you guys a couple seconds to get your votes in, and we can take a look at the results as well. Perfect. So most of you are creating those piping and instrumentation diagrams in-house. Some of you aren't, but would like to potentially do so. So that should be very applicable for what Michael's going to be going over today. I will pass things along to Michael to jump into SMAP 3D and what that software can do for you guys.
All right, excellent. Thank you, Connor. Welcome, everyone. Again, my name's Michael Mooney. I'm the Technical Director for North and South America at SMAP 3D. And yeah, what we wanted to do here was give you guys the opportunity to discover maybe something that that could help out with especially some of the questions or the answers to the polls there. Looks like we might have an opportunity to make you more proficient in your design process working with SOLIDWORKS. Now, as Connor mentioned, we are a gold partner of SOLIDWORKS. And so if you're not familiar with the SOLIDWORKS Gold Partner program, it is a program that has many different partner products, but also gold partners. And out of over 700 partner solution products out there, about 40 of them only are gold partners. And so that's the highest level of integration into SOLIDWORKS. And so what we see is single window integration inside of SOLIDWORKS. We have a couple of new tabs in the SOLIDWORKS Command Manager. Okay, one for our 3D piping, and then one for vision into the P&ID to-do list. The to-do list comes up over on the right-hand side in the SOLIDWORKS task pane, and this is vision into the P&ID. So we're not maybe looking at it right now because maybe my role is the 3D layout SOLIDWORKS modeler working in the 3D space. And a lot of times that 2D P&ID role might be handled by a different person or a different department within inside of your company. But then also many times these days, we're forced to wear multiple hats and duties in our job roles. And so it might be you are the one responsible for both disciplines. So it's nice to be able to see them here. I can split my screen here because it's very difficult to show dual monitors on a web meeting here. And so what we can see here is we have the P&ID over on the left-hand side of my screen. This is a separate standalone program that can operate without a license of SOLIDWORKS if your only duty was the 2D schematic. Okay. Or it can work in connectivity with SOLIDWORKS at the same time, like I have now, and we can actually come over here and click on things, and it will highlight the items in both windows of the programs at the same time. So you can see how does that 2D schematic relate to the 3D virtual environment inside of SOLIDWORKS, to where you can kind of see the real world look of things, and then how it looks from a logic point of view as far as what are the components inside of here and how are they connected to each other. All right. So another aspect of our integration with inside of SOLIDWORKS is I've chosen to split my feature tree in half so that I can have my SMAP 3D piping tab. We have a new tab up here at the top. So we have my piping tree up here at the top, and I have my normal SolidWorks feature manager, or any of the other tabs that I might want to play around with or access with inside of the bottom portion of the feature manager tree. All right, and so one thing that I'll point out here is just that this is a simple skid that a lot of our customers get into these days with doing things modularly, where we can build things in our shop in a controlled quality environment, and then put them on a ship or on a truck and ship them out to the job site and plug multiple of these units together to build up your plant, so that you don't have to have all of your fabricators out on site building these things. But we can work in both methods as well. Now, typically what we would do is start off in a process engineering environment. We typically start off in the 2D environment with laying out the logic of how things are connected to each other, and what items are going to be used, and what's going to be connected to what. And so with this, we can work with inside of the SMAP 3D P&ID solution here. This is a schematic capture tool. It is a project-based system. And what that means for us is that we have several tabs down here at the bottom, kind of like Microsoft Excel. And these different tabs can house different types of pages. So I have a cover sheet, a table of contents of what is all included in this whole project file. And then we can break things down into different chapters. So I have a diagrams chapter, I have lists and reports, data sheets, and symbol legends is what I have in my example. And so we can break these things out into different chapters. And this could be diagrams, it could be phase 1 or phase 2 of a process, depending on how complex your design is, because very often our customers will have hundreds of sheets in a P&ID project. Now, we are also in an intelligent P&ID solution. And so what does that mean? Instead of just an architectural tool that we've added on a library of blocks and call it a P&ID solution, we are a schematic capture tool from the ground up. Okay? And so what that means is that we are not just lines, arcs, and circles. We are intelligent items, to where if I don't know what a symbol is representing, I can hover my mouse over it and I can see, oh, that's a tube type heat exchanger. The article number is PK 400-35, and the unique tag number is W4100. So if you're not familiar with the symbol, it's easy to find out. If you don't know what size a pipe is, you can hover your mouse over it and say, oh, that's an 80 millimeter pipe. And then the very last item there, I see that the medium is PS for pure steam. Okay. And so it makes it easier to find these things out. Another aspect of the intelligence would be, it's very common that we run out of room on one page and we need to continue on to another page, like we see here with my pipelines here, where I got running off to another page or coming over from another page. And so we have a reference of where that is, what page, what row, or excuse me, what column and what row that appears on. And if we look up here at the top, we'll see how it's divided off into pneumatic columns or numeric columns and alphabetic rows. And so we don't even have to navigate ourselves. We can just double click on that and it will take and put your mouse cursor on where that pipeline continues on and whatever page it is. Is it page 2 or is it page 62? So being able to trace back your steps is much easier with this intelligent linking back and forth. With also that, we have, not just lines, arcs, and circles like we said before, but we have intelligence about what this particular item is. Okay, well, I got a 2,000 liter vessel. Well, we can actually go in and open up other items about it, see a picture, we can get into the actual database itself. And this is customizable by you because it's going to be different for every company of what vendors they use and those types of things. And very commonly, people will do a data dump from their ERP system and populate this database with all of their part numbers and their descriptions and things that are important to them. And this is also customizable. This is just an example form that we use here. So if there's pieces of information that are missing that are important to you, you can add it. If there's pieces of information here that are not important to you, these are all customizable. Okay. And so with this, this database of the physical descriptions and the physical properties of the actual components themselves, we're able to generate bills of materials from the P&ID. So we don't have to wait until the 3D data is done inside of SOLIDWORKS to get in here and update everything, or to generate a bill of materials. Now, in a P&ID, in a process engineering environment, this bill of materials is important, but it's not as important as like component lists and valve lists and equipment lists that might be, generally containing more detailed information here. And so we'll see that here I have a list that is organized by a single line item for each tag number or each unique instance. Because, for example, I might have, several of the same size and the same, model number of valves, but they might be, handling a different fluid medium at a different pressure, at a different temperature. And so we need to give it unique identifiers like these tag numbers here. And so the system's going to keep up and monitor these tag numbers that have been used to make sure that you don't duplicate tag numbers, which is not a good thing in a P&ID. It means that you've made a mistake normally. So yeah, getting in and finding these items is also a really easy thing. You might say here that, where is my V2008? I want to find that. Well, I can look over here that it's on page 2, column 3, row D, but I can also just double click anywhere on it, and it will take and put my mouse cursor on where that component is on whatever sheet it is. And so again, easy to find things and locate it from the lists. Also, these lists, you can export these to an external file, a text file, a CSV, various different file formats that we can do is getting in here and export out a component list. So we want, various different formats, text file, Excel, what version of Excel, or do you want an XML file, which is commonly used to communicate with your ERP systems. Okay. So if I come in and say that, yeah, let's just go ahead and generate a list here of all of my components. And so I've chosen just to print out my pipelines. Okay. And so we can see that we can format these things and put in all of the data. But you have full control in here of what information you want to be, contained in this external file. Now, also very commonly, we might want to show more detailed information. If we take a look here, we have a couple of pressure vessels, a heat exchanger. If I go back here to sheet 1, we'll see that, there's also another vessel inside of here. And so these might require some special reports that you could fill out and have a template for of what information is important to you. And so I have automatically generated by the system the reports pulling the data from the database that is important to you guys. And then finally, another type of report would be a symbol legend. Okay. Now we can come in here and generate symbol legends custom for each project so that it only contains the symbols that are used in this particular project. So it makes it much easier for the person that has to resort to looking at this symbol legend if they don't know a symbol that you've used, so that they can come in and find what they were needing an explanation of. And so these are automatically generated by the system. Now, if we get back over here into how do we actually draw things and use P&ID to create schematics? Okay. Well, we can come in and it depends on how you get data in here. You can either go in and place, kind of more generic symbols and things, maybe for a pump in here to say that, I need a pump. I want the discharge going this way. And yeah, it could probably be a little bit smaller. And so we can change the scale and things of that nature. But we can get a just a generic pump in here, and we'll say that this is going to be my P2002, right? But I don't know any data from that more than that because I haven't done the engineering yet. So we can go ahead and just place a symbol in here that doesn't have any part numbers or any intelligence. But I'm going to ask the system here, I'm going to ask, has this been used, this tag number, has this been used before? So when I click on it, it rolls up to 2004 because 2002 and 3 have already been used in this project. So we can come in and place that. We can put in any process-specific information that might be important to us. And then we have our, what we call a dumb symbol. Okay. And then later on, once you get the engineering done, you can go back and apply a part number to it from the database and apply all those physical properties. Another method would be is if you knew beforehand what pump I want to use, I can go straight to the component database here. And if you know your article number, you could type that in. I'm not very good at remembering those. So I might come in here and I might say that, oh, I'm looking for a pump, okay? And so I can type in pump for the type. And I got 3 pumps in here that I generally use that we can work with, okay? If that's not enough of a granular way, we can actually come in here and sort by any data field in the database. And we could say that, oh, I'm looking for the manufacturer of Apex for my pumps, or maybe one of our customers, Grundfos, GR, and it filters out everything that doesn't start with GR for the manufacturer. And I can come in here and I can see my pumps here and choose which one that I want to use here. And then I can come in and it goes and grabs the correct symbol for me, so I don't even have to worry about what symbol is supposed to be used there. I can place this onto my drawing, give it a tag number of P3000. I can say that this is going to be hot water. It's going to be at 90 degrees C, and maybe we'll design it for 95. We'll say we don't want it to get above 100. We can put in its pressure information, whatever is important here for you. And again, you can customize this, add and remove data fields from here, whatever might be important. So this is information that could go into a report. It also knows that whenever I spec out this pump, I also need a motor to be ordered as well. It does not come with the motor from the manufacturer whenever I order it, so I need to make sure this gets on my parts list so that we don't forget to order that motor separately. But I don't want a separate symbol like I have out here on this example. I want it to be one single pump symbol for that. Okay. So we can come in here and say that we're happy with this, and then we can come in and connect a pipeline to it. Now you see these little red diamond shapes on my my symbols here. These are connection points or nozzles that I can use to make pipe connections. Okay. And this kind of comes back to whenever we start getting ready to draw a pipeline, this gets back to our roots of being a schematic capture tool specifically. And so if I try to draw a pipeline that doesn't connect to something, the system's going to flag me. Hey, it's not often that you would just have a pipe floating out there in thin air. Did you mean to do that? If you did, you can park it out there in free space. Or were you trying to create a line link like this right over here to another page where it continues on to? Okay. In my case, I was just careless. And once I actually land on one of these connection points, the system will know, oh, okay, yeah, we understand what you're doing there. You're drawing a pipeline and connecting the 2 pieces of equipment. And once they get connected, they stay connected even when you move things around. And if you cross another pipeline, there's an option of how you want to put your brake lines in there. Do you want to insulate the pipe and show that on the P&ID? And then we can come in and we can tell it what is the pipe information here. Well, we need a tag number for your pipes. And so I can pull up a list of maybe kind of a cheat sheet of what my company generally uses for tag numbers for different types of mediums. And this is customizable just for those people that might be new to the company or less experienced and they don't know all of the rules or protocols. We can use these to carry on with. and say, hey, let's go ahead and count up from here, so we can get a new tag number. You can also get a list of all of the tag numbers that have been used in this particular project. Or you can altogether give it a whole new tag numbering convention, and we'll say that this is going to be my PL300. I'll ask the system, has this been used? Nope, it didn't change. And now I can come in here and put in my size and spec information, but I don't need to manually type that in. That's error prone, and I might key in the wrong information. So I can pull up our pipe specifications. So our pipe specifications are going to be custom for each company. Everybody does things a little differently, and so we might have different styles of pipe, bent tubing, copper piping, whatever it is that you use. Getting into sanitary or food and beverage kind of pharmaceutical grade piping. All the different aspects you can get into. Air ducts, so it doesn't have to be round pipe. It can be rectangular or whatever shape you want it to be. Cable trays, all of these applications are viable. I'm going to go with a spec named here spec 10CA, and I'm going to go with a 4-inch or 100 millimeter pipe. And I'll click OK to that, and it fills out all the information there for me. Okay. And then I can come in and I can put some more process specific information like HW for this is going to be hot water. And if I want to put temperatures and that kind of thing in here, I can. What type of insulation is it going to have? And these can also be drop-down menus that you can create as well. And so now it knows the actual information about this particular pipeline, and I can anchor the label up here at the top that just got created there, showing me the tag number, the size, the fluid medium, and the name of the pipe spec. Okay. Now these labels are also customizable so that you could show more or less information on your diagrams as well. Now, pipe specs do more than just quickly create or quickly apply pipe information. They also can help you determine what type of equipment I should place in here. I need to place a valve into this pipeline so that I could shut off the fluid so to do some service to the pump. Okay. And so instead of going to the component database and coming in here and choosing all the valves that we have to offer or that you have in your database, and picking the wrong one, because it would let you put the wrong type or wrong pressure rating, wrong temperature, or even the wrong size in there if you wanted to do that. You can actually use the pipe specs. I'm just going to cancel out of there. You can right click on a pipe and tell it that you want to place from specifications. And now this will look at your pipe spec and it will say, okay, well, here's the 4 pieces of approved equipment that I have in my pipe spec that matches this size and pipe spec that I'm working with. Okay. And so in my case here, I'm going to go with this globe valve. Okay, this fits my needs perfectly. And again, it goes and finds the symbol for me that's supposed to be used by that globe valve. And I can place it right into my design here. And we'll say that that's going to be a V3000. Okay. This is for my tag number. Has that been used? No, it hasn't. And yeah, I'll say that I'm happy with that. And by the way, we don't make valves at our company. We purchase them and put them into our designs. Same with pumps and that kind of thing. So these purchased parts, using the power of the database, you could actually come in here and say, hey, show me the spec information, the pipe spec sheet for this particular valve. And so I see the spec sheet from the manufacturer that has all the details right there. I don't even have to do a web search. It's right there at the engineer's fingertips anytime that they would need it. So this is very handy as well. All right, and so it goes ahead, it rotates the symbol into position for me, and we can come in and we can see all of the details and those types of things here, and we can even sell it that maybe I want to remove that piece of pipe and put this right down on the nozzle. So this can go anywhere along the pipeline that you wish. Now that we have all of that in there, we can come back to our reports here, and I can go in and tell it that I want to update all of my lists. Okay. And so here it says, well, you've run out of room on one of these pages. You need more pages. Do you want to go ahead and insert them wherever needed? Yes, absolutely. So now I got 3 component list sheets because it spilled over onto a 3rd sheet there. And I see all of my new components here, my P3000 for my pump, and then I see the P3000 with a different part number for my motor. Okay, making sure that I get that onto my bill of materials there and be able to communicate that easily. Okay, so I am going to talk about, yeah, we got all that in there. And then depending on your needs, sometimes you might need to come in and show this with insulation. Okay, so that's just a right click and turn it on or off. If you don't want to see insulation, again, turn it on or off with the little button here. Now, being able to communicate this information with other people, maybe I want to share this data with someone else in my company that doesn't have access to a license of SMAP 3D, or maybe the customer or somebody outside of my company and they also don't have SMAP 3D. So I can, while we do have a free viewer, there's some challenges with free viewers of, downloading the software and having permissions to install it and just going through the whole process of having to find a viewer for it. So we can actually export out to a DWG or a DXF or a PDF. Okay. Now, a lot of times people will ask for a DWG or DXF, but you need to make sure that before you just send them that do you really want to send them that kind of file? Do you know for a fact they have a program to be able to open up that file type? And the other issue with that sometimes is that this is not a secure file format. Somebody with AutoCAD or DraftSight or SolidWorks, for that matter, can open it up and edit it. Okay? And so with a PDF, this is secure. Anybody with Windows, which is what we have to have for SolidWorks anyway, can read a PDF without any additional software these days. And you have full control over what pages do you want to send this person. Okay, do I want only the diagram sheets or only a certain diagram sheet? Do I want all of the sheets? And then what data do I want to share with them? That pop-up information that I was hovering over, do I want to allow them access for that? Okay, I can turn that on or off. I can control, the image quality or the file size. Where do I want to save it? All that good information. But if I do want to include that intelligent pop-up information, do I want to share all of that data with them? It could be that there might be certain pieces of information in here that I didn't want to get outside of my company. Okay, and so I can come in here and turn these options off, and so that it's more secure and I don't let any secret information out. Okay. And we can also make these quick setups here, and I have one that I use for an external facing document where I turn off all of my proprietary information. And then I have one for an internal facing document that I have all of the information turned on. And then we'll come over here and we'll say, okay, and it's like, oh, by the way, do you want to update your lists before you create the PDF? Yeah, that's actually a good idea. Let's go ahead and do that. And so now it packaged everything up into a 17-page PDF. I'm using a Adobe Acrobat Reader, just the free reader. It doesn't have to be the Adobe brand or anything like that. Just to get the intelligence to come through, you would want it to be a viewer that supports the ActiveX controls. But I'll see that I have my entire project bundled up into a drawing package as a PDF, which is most commonly this deliverable these days. And when I click on things, I can see that intelligent information. Okay, the line links work from page to page. Okay, I can see this intelligence that I typed in here. And so, yeah, this is basically the full capabilities of the viewer within inside of a PDF. Okay. So no software to install, and also I don't have to worry about people changing it. Okay, it's a secure PDF. Our line links work. So if we wanted to come in here and find out, hey, where's my V3000? Boom, it zooms in right to the general area of where that is on that sheet. and I can have easy access to it. Okay. So our Smart PDF is a very great collaboration tool that is just included in the software. Now, how does all this information get back over into SolidWorks? Okay. We need to do the 3D side of that, all right? And so we can come in here, we can save that, we could check it into our SolidWorks PDM and trigger a workflow that gets a notification to the 3D user that, hey, I've updated the P&ID. You need to go ahead and come in here and reload your P&ID, or there's also a refresh button there. I had accidentally turned mine off. But whenever you turn it back on, it does the resync anyway. And now we'll notice that it's not all green over here anymore. I got some orange sections or orange items in here. The orange items are things that exist in the P&ID, but they don't exist in the SolidWorks model yet. Okay. And so I like to think of this kind of like when you go to the grocery store, a lot of times you'll make a shopping list so that you don't forget to buy the critical grocery items. This is the same kind of thing so that we don't forget to put the items that the process engineer put into the P&ID into your SolidWorks model. Okay. And so also I have a labeling here or a classification of what's main equipment and what's inline equipment. The main equipment has a blue dot on it, and that was just a checkbox over in P&ID when I placed that component. So I know that I need to put my main equipment in first because pipes connect to that, and it's going to be very difficult for me to connect a pipe to the pump that doesn't exist yet. So I'll come in and yeah, we can use any method that you want in SolidWorks to insert a component, right? You can use this, but then I need to know where is that? What model do you want to use? Well, I don't know. This process engineer told me what it was supposed to be. And so with SMAP, you can actually come over here in the to-do list. We can right-click and tell it that we want to place the model into CAD. And from the information from the database, it knows what 3D model is supposed to be used and loads it up into the insert component command. Okay. And so from there, we can just use our normal SolidWorks tools. This has a mate reference in it, so I can use my small SolidWorks Smart Mates to pop that into position, or I can go through my normal mating process of creating my mates manually if you wish. So now it's assigned that component. It turns it green. Life is good. We can move on here. Now, do we want to have more granular control over that pump and the separate motor? If so, we can come in here and we can actually assign the components manually. Okay? If they aren't something that you use on a regular basis, you could just download the assembly, put it into your SolidWorks model, and then manually assign things as well. Okay? So it really works both ways as to what fits better into your workflow of how you get data into your company or for your designs. Now we know where we're going there. I can move down here to pipelines. Okay, we can look at things in the P&ID to-do list by just pure components or organize them by pipelines. And then we can see what components are in these pipelines, okay, what they connect to. And so I have my PL300 that's also orange here. And I see that, okay, I got my heat exchanger and I got my pump. My valve hasn't been placed yet, but I'm not ready to place my valve because I still haven't created the pipeline. Now, the question here is going to be as to what nozzle am I going to use for this pipeline? Okay. Maybe I don't already have that in my head. I might not be as experienced as some other people in my company, so we can rely on SMAP to help me out with that as well by telling me to show me the from to points for PL300. And so I show that, and it's going to come out here, and it's going to put red balloons on the nozzles that are used by that pipeline. Okay. So now that I know where I'm going, I can get those out of my way. I'm a big right clicker. If you like toolbar icons, we have those up here as well. Just from my history in use of SolidWorks, I've always been a right click person. So we have them in both environments there. And if we look over here, we can see that I have each pipeline spool in its own subassembly. Okay. This is not a requirement, but it sure does make life easier on me to have that organization within inside of there. And SMAP will help you organize things so that I can actually come over here from the to-do list. I can right click and tell it to create a new route. And when I do that, it's going to ask me, do you want to create this in a new subassembly? Yeah, absolutely. Let's do that. I like that organization. And so it's going to create a new subassembly here. And notice that it named it here PL300 to match the tag number from P&ID. Now this is a blank new empty assembly. The only thing that it has in it is a 3D sketch, okay, named piping 1. So it created a new assembly, edited that assembly in context, and now we're in a 3D sketch ready to draw my path from how I get from point A to point B. So do I want to manually draw that route with a 3D sketch, just a regular SOLIDWORKS 3D sketch, and use those tools? Or is it something in that way I have full control over what direction it goes and how far and that kind of thing? Or in this case, this is pretty simple. I could do an auto route, okay? And so with my auto route tool, I can just come in here and, select the nozzle that I want to go from and the nozzle that I want to go and connect to. And we have a little bit of control over this once we get it going, but it's going to create an orthogonal line of best fit. So I can make it closer to the heat exchanger, closer to the pump. I can tell it that I want it to go down first before it goes over. And then I can say, yeah, I'm pretty happy with that. If I want more control than that, I could also tell it that I want it to allow it to go in an angle there if you wanted. But if I need more control than that, I need to use the manual route. Okay, so I get a preview here, and I can already tell with the preview that I'm going to have an interference problem. So I can go ahead and move that out of the way. Okay, and we can close our auto route. We can move that out of the way, get it nice and clear, and then maybe we might say that, let's just add a dimension to that so that we don't have any interference problems in the future. Give it a little extra space there so that we don't have any clashes. And then we can say, okay, I'm happy with that. And whenever I close the sketch, it's going to go out and import the data from the P&ID about what size and spec is being used. And then it renames it here. And one thing that I forgot to point out before I click OK right here is that this, actually I did point out that it was a blank empty assembly, no mates or anything. And so when I say, okay, our piping engine is going to kick off and build the assembly for me. So really the only thing that I've done in SOLIDWORKS was I placed the pump and made it into position. It told me what 3D model, and I drew the path of how it gets from point A to point B. And then the SMAP piping engine did all the hard work for me as far as putting in all of the correct fittings so that it knows whether or not you want to use welding gaps or not. Notice in the background here, I have another pipeline with weld gaps in there. This is just an option to turn on in your pipe spec because some companies want to design with pipe specs to get more accurate cut lengths of each piece of pipe. Other companies say, we leave that up to the shop, let them figure out their weld gaps. We use different shops all the time, and yeah, we don't want to commit to a specific weld gap and then it costs us more money or not be able to do it. It also knows that based on the pipe spec, whether I'm using a short radius elbow or a long radius elbow, do I need welding neck flanges instead of slip-on flanges? Is it threaded? Is it socket welded? All of that information is stored in your pipe specification. And remember, you can have as many pipe specs as you want. The SMAP 3D piping engine was also intelligent enough to know that, this interface here, I need, on this particular instance, a 1.5 millimeter PTFE gasket in here. Okay, and so it inserted the gasket in there as well. And now if I come back over here and look at my SOLIDWORKS feature tree, we'll see that we have all of these part files now inside of here where we can see all of this. We have all of our mates, all of our pieces of pipe, and it's created all of these standard SOLIDWORKS mates in here, coincident, things of that nature. So what does that mean? And why is that important? Is because with this pipeline and all of this piping that I'm doing with SMAP, I can still share this data with anybody that has a license of SOLIDWORKS or eDrawings for that matter, since it's a viewer for SOLIDWORKS models. and they can visualize and work around my piping. The only time they would need a license of SMAP 3D would be as if they wanted to edit this pipeline and change the size or add a branch, or if they wanted to create a new pipeline. So completely compatible with just regular SolidWorks. These are all native SolidWorks parts and assemblies. And so we've just automated all of that and made it look like you've spent a lot of time doing a lot of work building your own pieces of pipes and extruding them and that kind of thing. Now we're almost done here. We just need to come in and place our valve. Now, where do we want to put our valve? We can put it anywhere along through here. The P&ID shows it on the nozzle up here for the heat exchanger. But me is also responsibility for being one of the safety engineers for our company. I see that somebody would have to climb up this ladder, straddle over these hot pipes to turn off that valve. And so maybe I want to call an audible here, and I want to say, oh, let's put that valve down here to where it's more accessible from the ground level. And so you can do that. Okay? And we can just right click and say, place the 3D model into CAD. Again, it goes and it finds the model that's associated with that part number from P&ID. We have our mate references in here so that it knows how it's normally positioned and mated into an assembly. And then we can come in and we can tell it, yep, that looks good. We can flip our direction here. Okay, we also do have a design check to see if something did get put in the wrong direction. So you can capture that and correct it before it gets out to the shop. And so then we can just finish this off by creating regular SolidWorks mates. Okay, so all the tools we're used to always using in SolidWorks, we're still leveraging here in SMAP 3D. Okay, we can clock this into position and say that I want that to be parallel to that line so that it doesn't rotate and get into a bad position. Checks it off green there for me. I got big check marks on the top and bottom. The only thing that I need to do now is right click and recalculate my pipeline so that it can cut this piece of pipe, create a new piece of pipe, but it's also going to cut it back far enough to accommodate a welding neck flange and a gasket on each side of my valve. Okay. And it's pulling that information from the connection information that we've added into our equipment. Okay, so that valve, it knows that it's flanged, so it puts a flange and a gasket in there. Now, from this point, again, we have just native SolidWorks parts and assemblies. So you can still use all of the great SolidWorks tools you're used to, like simulation and SolidWorks PDM, Composer, Flow to do fluid flow analysis. So all of these tools are available, including your SolidWorks drawings. Okay, so if you like that kind of more 3D looking, SolidWorks projected views, you can continue to use that just as you do today. Okay. But a lot of times our customers need to have these single line isometric drawings. Okay, and so to create that, I can come in here and click two buttons, one to start ISO and then click my finish. And it will go in and convert this 3D model into the single line isometric. A lot of times people refer to it as Isogen drawings. And I don't have to do anything. Okay. Now I'm going to run it on this one pipeline here. But if I would have run this from the top level assembly, it would have taken about 4.5 minutes. But after that 4.5 minutes, I would have 37 drawings done in this particular model's case, because it would have gone from the top level and batch generated all of the drawings for me. Okay, this one took about 20 seconds, and I can see here that I got a DWG, and I also have it automatically generated into a PDF. Okay, and so I don't even have to open this up into SolidWorks or eDrawings or run the SolidWorks task scheduler to convert this to a PDF. Okay, I got it right here in a DWG. I also have it right here in my PDF that I can come in here and see my elevation callouts for all of the connection points. I see my northing and eastings, the dimension styles. You can change the styles. Maybe you want to dimension to the welds. Maybe you also want a dimension to weld gaps. Maybe you only want to do center lines. You have full control over how you want these to look. Converting the 3D models into the relevant symbols. So this is a valve, but also notice that it imported all the way from P&ID down and through SolidWorks into the ISO drawing. I see the tag number from P&ID. Okay, so this is done. I don't have to touch this drawing. It's complete. Okay, and so most people tell me that whenever they have to draw these manually, which SolidWorks doesn't do this, so you would have to manually draw it in SolidWorks or in DraftSight or whatever you would use for your traditional 2D CAD. They normally tell me that it takes about an hour for them to do that. So here I see also the size and the quantity of, I need 3.9 linear meters of 100 millimeter pipe for this. And oh, by the way, I did not put the flanges or the nuts and bolts into my 3D model, but the drawings map is intelligent enough to know that I'm going to need 64 washers and 32 nuts and bolts based on the types of connections that I've used here. Okay. And then I also have, I know that it's 3.9 linear meters, but I also see that I have each individual cut length broken down in the end preparations that we have here. And so this way, no matter who in your company is going to generate these pipe drawings, it's going to look standardized and consistent no matter what user creates them. And so it's going to be much more efficient for your shops to have a standardized look and feel. And you don't have to do all that work yourself. As I said, normally it takes about an hour per pipeline to draw these by hand, sometimes more, sometimes less. And so that's really our workflow of going from the 2D P&ID, bringing that over and reusing that data instead of having to re-enter it a second time and hoping I didn't forget something and make a mistake, get it into the 3D model in SolidWorks, and then out to my deliverable single line isometric drawing. Okay, so I'll turn it back over here and see if we have any questions that we can address.
Yeah, Michael.
Sorry, Connor.
No. I just wanted to say thanks to Michael. Always impresses me, kind of the automation built in throughout SMAP. But yeah, we can jump right into questions. Madeline, did you want to ask those for Michael, or I can do so?
Yeah, I can ask them. We do have a couple of questions that are in the queue already, so we'll go ahead and get started on those. The first question I have here is, do we need a SolidWorks premium license to use SMAP 3D piping?
Great question. So we don't use any technology from SolidWorks routing. We have our own piping engine. So we work the same with SolidWorks Standard, Professional, and Premium. So it's not a requirement, no.
Awesome, thanks. The second question I have here is, what kind of SolidWorks license is required for P&ID?
Okay, so that really depends on your role. If only P&ID, we do not require a license of SolidWorks at all. You do not need any other CAD tools on your machine. P&ID is a standalone application. But if you do have the 3D requirements, they can be installed, as you saw on my computer, in tandem and work a little bit closer together.
Great.
So it's not required to have a SolidWorks license for P&ID.
Awesome. Does this work with SolidWorks PDM?
Yep. We're generating native SolidWorks parts and assemblies. And so the only thing you would need to do is if you wanted to get P&IDs controlled, would just be to create a data card in your PDM for the .pro file format. And then we can integrate that. And we're actually looking at maybe in H1, possibly even Q1 of next year, of having some buttons with inside of P&ID to have a direct check-ins, but right now it's just as if it was a non-SolidWorks document. You would check in the P&ID, but everything else is just a SolidWorks file.
Awesome, thanks. And I have another question, and it is, can we use your isometric drawing tool with SolidWorks routing?
Okay, that's actually a very common question that I get a lot of people that already have 3D done in with SolidWorks routing, but they need isometric drawings. And the answer to that, unfortunately, is no, because SOLIDWORKS routing doesn't have any ISO information, any Isogen information in it. So Isogen doesn't even know what it is, and so you'd have to manually program that for each pipe run. So you would have to redo the piping with our piping engine for Isometric to be able to be used.
Okay, and then we have time for one last question here, and it is, if I make a change to the SOLIDWORKS assembly, will it update the P&ID?
Ooh, that's a good one too. So the question for that, or the answer to that, is no. And it's not a limitation in the program. It is that it would violate so many rules of process engineering that all of our customers begged us not to let that happen. Because in process engineering, your P&ID is your controlling document. And so we've made it to where the design is born in P&ID if you want to work connected. And then the changes would happen from P&ID and flow down into SOLIDWORKS. They do not go backwards and modify your P&IDs. Another kind of spinoff to that is just know that it is not required to create P&IDs to use our 3D piping. We have some P&ID only customers that don't do 3D. We have some 3D only customers that don't do 2D schematics. And so they are not required. But if you do have to do both of them, then we're definitely the right solution, because then you don't have to duplicate data.
Great, thank you, Michael. So that is all we have time for today. If any questions do arise after we finish here, please do not hesitate to reach out to your account manager or reply to the webinar email, and we'll be in touch. Thank you again to Connor and Michael for such a great presentation, and thank you all for joining us here this afternoon. We hope to see you again soon. Thank you.